Okay, my name is Danny Forster, and I am the architect of the Cantor-Brecken House here in Omena, Michigan. I'm also, I guess, for anecdotal sake, I'm also the host of Build It Bigger, a show about architecture and design and engineering on the Discovery Channel. But I am an architect. I actually recently graduated from the Harvard University Graduate School of Design. So despite the TV thing, I'm actually a legitimate architect, and this is my first solo project, my first project I've done not working at a firm. And how I got involved, I know the clients through family friends, and basically they wanted a house that would be green. They wanted a sustainable house. They had bought this piece of land, they had a small modular home on the property, and my interest has always been in sustainable design. But I'm not really interested necessarily in all the high-tech gadgetry and then the sort of the solar panels, which is great, but we tried to take this house's design philosophy from a very basic, passive logic. We wanted to think about, where does the sun rise? Where does the sun set? Where does the wind come off the lake? And design the house around that. Although it's a somewhat unique and unconventional looking house, I think some of the most important stuff about the house are the unique and unconventional, sustainable and environmental techniques we have in the house. So come inside, let me show you a little bit about what we're doing to make this one of the greenest houses ever built in Michigan. So we're still very much under construction, but when you come into the house, one of the key things I think you'll notice is that there is no traditional air conditioning or heating. What we're doing is something a little bit different. You see, you typically have radiant floors, hydronic tubing, and you put them in the floor below you. But what we're doing, our kind of innovation, is taking those hydronic tubes and hanging them from the ceiling. Now, you're saying to yourself, why would you do that? Heat rises. Well, heat does rise when it's convective, in other words, forced air, traditional air conditioning, traditional heating. We are using electromagnetic heat, just like the beams from the sun. It comes down like a laser beam. So instead of shooting those laser beams up to heat the bottom of your rug, to heat the bottom of your table, we're going to actually shoot those laser beams down and hit your head, hit a tabletop, hit, the part of the chair where you put your rear end. But for us, the real innovation that's never been done before in a house is that in the summertime, we're going to run through those same tubes hanging from the ceiling cold water. So this is something called a thermally active surface. So imagine that. You walk in from the beach, you're totally hot, your head is hot, but because of that cold, chilled ceiling above you, the heat from your head should get sucked off and go right up to the ceiling. Now the beauty of this logic, this thermally active surface, or what we're calling a chilled ceiling, is that instead of having to cool and use all the energy to cool the entire house, every inch of it, even parts of it where you're not, we're just going to cool you, your head and your body. Because even if the corner is a little bit warm, the important thing is that you feel cold. So the great thing about this system is you get heating and air conditioning in the same system, right? You build less. But also, you're going to use much less energy. Now, addition to that fact, we're also doing geothermal heating. Now, we're taking a site that is waterlogged, right? We're on the water, we're on the lake. We're taking that water, running it through the earth, letting the earth heat or cool the water, then using that water to run our systems. So we're taking a waterlogged site, using a water-based HVAC system, and getting one system to get both heating and cooling taken care of. So that's some of our let's say, our high-tech innovations. Now let me show you some of our more low-tech, sort of simple, logical green innovations. So come this way. So as you walk through the house, one of the things you'll probably notice is that, the windows are in very funny places. And you're saying to yourself, that's some crazy architect trying to be an artist. Well, it's not that. You see, if you come into this bedroom here, every single window, every single room has been placed very specifically based upon what we know about the sun and the wind's movement. We actually used a software called Ecotect. Should I keep going with the noise? Okay. We actually used a software called Ecotect to let us track the path of the sun and the path of the wind. So for instance, in this bedroom, we know wind is going at this direction. So we open these windows to bring wind in, our intake, and we bring our wind out through here. So as you look from the outside of the building and you see the windows kind of dancing around in different locations, we place them very specifically. Again, for example, this is the office, to bring wind in from there, and that wind will go out that window. So you're asking yourself, oh, there goes that crazy architect again. Not at all. We're very simply trying to passively cool the house. So instead of using your heat or using your air conditioning, if you're hot in the summertime, just open that window and then open that window. And for me as an architect, what's really important about this idea is that you have the responsibility to control your temperature. And I don't mean by walking to a thermostat and turning it on. We believe that the house should be worked and used like a tool. You should know that in the morning, and we'll tell you this, that the wind comes this way. So we have the windows there. But we know in the afternoon, when you're having lunch, it's over there. So you open different windows. So throughout the day, you yourself are gonna move, adjust, open and close different windows to kind of control passively your own internal temperature. Now, I'll show you another thing. So that's the wind, but what about the sun? So, and being able to track the sun's path, which, I mean, let's be honest, you don't need software to know it rises in the east and sets in the west. But however, we asked ourselves a pretty simple question. If the sun rises in the east in the morning, where are you going to be in the morning? Well, we assume you're going to be in bed. So we located the 3 bedrooms. Now you're coming upstairs. You know, with relatively basic logic, we said bedroom 1, 2, and 3 should be facing east. So when the sun rises in the morning, you take advantage of that light. Pretty basic, pretty simple. This is the east, this is the bedroom, bedrooms look east. But then we said to ourselves, as the sun moves throughout the day towards the south, that's when it gets tricky. Because in the south light, that's the harsh light. That's the light that ultimately heats up your house and makes you turn the AC on to bring down the heat. So when the sun is in its highest point, just cooking the house in the south, we actually cover our windows. We use what's called a rain screen. Our facade, our siding, is actually not attached to the house, but rather hanging off it about a 1/4 inch. And we literally cover our windows like a screen. So in the east, we get that sun because we want it. In the south, we block that sun because we don't want it. We want to keep the house cool. And then, come say dinner time, it's about 4, 5, 6 o'clock. And at that point, the sun is beginning to set. You want that light. So we put all the public spaces, the kitchen, dining, living room, right here. And although this will at some point be a glass wall, as the sun sets in the west, you sit on the deck, take advantage of those waning hours of light. So we basically, not only do we place our windows to catch wind, we place our bedrooms and other rooms to follow that sun, either taking advantage of it or blocking it when we don't want it. Whew. Okay, one last point. And this you'll need to look at a rendering to understand, but I'm standing right now in the kitchen, dining, living room. Now what's really exciting about this space is that you can't see it right now, but this whole wall is glass. This whole wall is glass. But this whole wall, you have 3 walls of glass. And that is actually a covered courtyard. The idea being that you can be in this space, you can be outdoors, you can be smelling the lake air, and still, let's say if it's raining or snowing, you have a roof over your head. But the exciting thing is we're using this type of wall called a nano wall. So imagine this. 5 9-foot tall, full height panels of glass, all by the way thermally broken and low E rated. In other words, they keep the heat in. But this entire wall of glass, with just a simple push of your arm, will completely and totally disappear. In other words, this one room, this kitchen, dining, living room, will be outside. So that 800 square foot deck you see out there will be part and parcel of this room. A nice little trick we have is in the balcony above, we're hiding screens. So with the garage door button you'll press, a 14-foot long invisible screen will drop down and keep out those horrible Michigan black flies, which I'm told are really horrible during the summer. So this is our living room space. Now maybe I can take you outside to explain some of the facade and the different materials we're using. So follow me.